It's
A or
giraffe.
yeah.
It's giraffe.
Okay. Wow, so busy, man.
What?
WhatsApp message. So many WhatsApp message. So, Giraffe, can you guess the mouse?
I am muted. You can't hear my WhatsApp.
Giraffe,
It's
No.
not me.
Okay.
I don't
It's
know.
actually
Giraffe
Aaron,
said.
I bet. I bet it's actually
240 grams.
240 grams.
I
So
don't know.
exact.
Yeah.
Okay.
0.24.
Anyone? Any other guess?
0.15.
Okay. Okay. I think it's okay for you to lose these 2 questions marks because
Wow.
I can't give you all the objects and then okay. Both of you get the mark. But no. Just everyone get the mark. So if you look at the marking scheme, it's from 0.05 to 0.2. Okay. I can't give you any hint to do this kind of questions. So for
Wait,
next one,
0.05?
So like 50
CM
grams.
pupil. Oh, okay. Okay.
Wait,
next
sir.
one,
Sir, when we do the questions later on, then are you gonna mark us according to the guess of mass and volume of mass that we put, or are you gonna mark us according to the marking scheme?
Yeah, mark it according to the marking scheme.
So we have to copy the answer for the first question.
What do you mean?
Because we can't. Yeah.
I understand what do you mean. Let's say if you are drawing on a single line paper, and then you just let me think. Most of the question is fine. So you just write down the question number and then give me the answer. Just like question 1, part A, part 1, and then, or you just write a few more words, okay, for me to easier to mark it. Just like this one, okay? Okay. Or I like this one, it's also fine, okay? Any other question?
No.
No, and then let's go on. So, can you guess the volume of the cricket ball of it or a tennis ball?
150 cm cube.
150. So how can we do this kind of question? You have your ruler, okay? And then, first of all, you can guess the radius of a cricket ball or tennis ball.
I can't.
You can't guess it? You don't have that sense?
I don't, I'm
I
sorry.
think the radius may be around
3 centimeters.
7
Yo,
cm.
why is this a question? It's legit just guessing.
Exactly, why is it
Just guess.
Yeah, it's just
so
make
dumb.
estimates.
So I check it online
Like
and then it say it's 2.7 inch. Oh yeah, roughly what I guess around 6.5 cm to 6.8 cm.
Radius?
So, and radius.
Radius?
Yeah.
How are we supposed to know that?
No, you just guess it. You you take out your ruler. Have you ever touched a tennis ball?
I won't
Oh,
have
yeah,
a ball in
yeah.
the exam.
Yeah, we won't have it in the
Next week,
exam.
You have that questions in exam, okay? And then you take out your hand, okay? And then if you have ever touched the tennis ball, and then get that feeling, okay, on your hand, and then I think you can do such a.
Yo, I'm just going to lose these 2 marks, you know.
Okay. If you lost this
I'm
2
not
marks,
So
I won't bring you, okay? Okay, let's go on, okay? If you lost these 2 marks, you can still get A. Let's go on to next question. Calculate the density. So the mark is the mass given, yeah, given here already. Appropriate number of certain figure with its absolute uncertainty. Wow, 5 marks. Whoa. So first, can you find the density? It's mass over volume. So do it by yourself. I'll do it in my calculator. The formula of the volume is given in the question. Wait. Oh. I'm so confused. Have you get the answer?
Can you explain?
Explain what? You're given all the values, D, L, M, and then you need to find the density.
So
Density is just mass over volume. Even you don't know about the volume, the formula of the volume of a cylinder. The formula is given here already.
yeah.
So
Did we find the errors of each value and then add it, plug it into a formula?
you need to convert these unit into SI unit, meter and kilogram,
Yeah.
and then put in the formula and then get the answer. Any question? So is there any question?
No.
So do all of you get 7900?
Yeah.
If yes, then we go on. So how can you get the uncertainty?
You can calculate the percentage uncertainty
But yeah, so
of
the
like
percentage
each of them.
Is the percentage uncertainty of the mass plus percentage uncertainty of the volume.
Yeah.
And then if you look at the percentage uncertainty of the volume, 2 times the percentage uncertainty of D times the percentage uncertainty of L.
Yeah.
isn't it plus for
Plus.
percentage of L?
Yeah.
Yeah.
You want to trick us, right? I knew it.
Yeah.
Oh, yeah.
It's plus, not times.
Okay, so the overall, the percentage uncertainty of density is the percentage uncertainty of mass plus 2 times percentage uncertainty of the D plus the percentage uncertainty of L. And then use your calculator. I think it's roughly 6.1%.
Wait.
Is it what you get?
Singapore. Yeah. So. Yeah.
So this is around
6.11.
500 here. Oh no. Yeah. 500. Any other question?
No.
No, and then let's
Wait.
go.
Okay. I'm still confused about the significant figures.
So you have a look. There are how many?
The SF has to be same, right?
Yes. So the minimum significant figure in all the data is
2.
2. It's given here. The D 0.38. So the minimum is 2.
The answer has to be 2SF.
Yeah, the answer should be in 2SF. So if in 2SF it should be 7900, and then 7900, and then plus or minus, you should have the same. We call decimal place. So the last digit is 100. Okay, 100, 900 here, and then it should consistent decimal place. Why I say consistent decimal place, even that there is no decimal place, because we usually write the answer in terms of the scientific notation. So in terms of the scientific notation, they have the same decimal place. Okay, understand?
Okay.
If no question, and then we can go on to next question. This one, obviously, if you have a look at the question, obviously, it is about the projectile motion. So the first question, even they don't ask you, you need to know, we need to decompose the horizontal component and the vertical component of the velocity. So the horizontal component of u is 50 times sine or cosine. Sine or cosine? Cosine.
Is it cosine?
Yeah, so it is 50, sorry.
Cosine 50
12
equals
times cosine 50 degree.
Oh, yeah.
And then make sure your calculator is in degree mode in physics exam. So it is 7.7.
7.1.
Oh, 2SF, because 12 is 2SF.
Whatever.
So for next question,
12 sine.
12 times sine 50. You need to write me the step, okay? For your homework. To make sure okay? So that the maximum height reached by the ball is 4.3 meter. So can anyone write down your answer here? How do you get the maximum height?
What is can you scroll up? Is there any more information?
No.
Oh my gosh.
Just look at
Is it like AT squared or something?
Isn't it like one of those vector formula, like S equals to UT plus half AT squared or something?
Yeah.
I already forgot,
Too cool. And then T line using.
So you will get. So what? You
What are you writing?
Yo, who's writing that?
Yeah,
Whoever
who's
wrote that is a
writing?
legend.
So how can you do this?
S equals to U V
S equal UV.
Too
U.
good.
Now, at
No,
the
no.
height,
UV light.
for the maximum height, it is the vertical displacement. So you need to use the vertical component of U. And then at the highest point, the vertical velocity at the highest point Q is 0.
Just use SUVA, the formula.
Yeah, so that formula without T is V
Too
squared
good.
equal to U squared plus 2AS. And then the final velocity is 0. U is 9.2
9.2
square.
9
8
minus 9.81.
9 minus 2.8 is 1 because if you take upwards to be positive and then the downwards vectors should be negative, and then use your calculator to get the answer.
What's that? 4.31.
4.31.
2SF.
Yes. So it's 4.31, okay? And then you say roughly is 4.3 meter, okay? And then determine the displacement of PQ. How can you do it?
How many marks for C?
4 marks.
Find the T and find
Mhm.
the S.
Mhm.
You can just find the time, and then you can find the and then you can times it by the horizontal component, and just use the Pythagoras theorem.
Huh? Can you speak again?
You can find the time.
Yeah.
The time to go up to the maximum height,
Mhm.
and then you times it by the horizontal component to get like the range covered,
Yeah.
and then you use Pythagoras theorem.
But this question may be a little bit tricky because it's not asking about the horizontal displacement or the vertical displacement. It's asking about the displacement PQ. That means the distance between P and Q. So you need to find the horizontal displacement in this question. This one, okay? Let it to X. So how can you get the time to the highest point?
Use any equations related to T.
V equal to
substitute
U
with
plus
it.
AT.
You are so helpful.
What?
So you just use V equal U plus AT, okay? This is the vertical motion. And then U is 9.2, A is negative 9.81 times T. And then you can get the time. What is the time? It's 0.94 okay, second. And for the horizontal displacement X, you just use a horizontal component times the time. You get 7.2 meters. And then for the displacement P to Q, you need to use the Pythagoras theorem. So the displacement is the square root of 7.2 squared plus 4.3 squared. Okay, so final it should be 8.4 meters. Okay. If no question, let's go on to the next question. A ball of 150 gram rests on the horizontal floor. And
We
then
didn't
find
do this before.
you did it before?
Yeah.
Now the method of the no motion, maybe just do it fast, okay? It's just equal to the
Wait.
weight. So it's roughly 1.5 or 1.47 Newton. Explain your working. This is the most difficult part, is it? Because you say it is it rests on the floor, so there's no net force. The outward force balances the downward force. So and then maybe just let's have a look at the marking schema. Okay, you can either say either one will give you 1 mark.
Mm.
So for but it's better for you maybe write down like this one. The normal contact force equal to the weight downwards. And then just like the sentence here. Let's go on to the next part. Okay, you need to remember the value 6.2 and then 2.5. 0.12. State the second law of motion. Do you know how to?
Change in momentum over time is force.
Is the net force. So you say the net force is the rate of change of momentum. Okay. And then, okay, let you see, have a look at it. Okay. The force is proportional or equal to the rate of change of momentum. So next one, calculate the FH resultant force in contact with the floor. So maybe you do it by yourself, okay? The mass is 150 gram.
What's the time?
1,
2.
Given in the question.
I always don't know how to write the direction thing.
What do you mean by direction?
You know the direction.
Of.
Like in part 2. Yeah. You also have to find a direction, right?
No. Oh.
Like I don't know how to do this.
You first find the material first.
10.9.
So you just find the change in momentum. That is when mv minus mu over time. Mass is 0.15. Final mass is 2.5 minus, okay? And then you need to care about the direction. So the two velocities are opposite to each other. So one of them should be negative. Okay. And then what do you get L1? 2.9?
10.9.
So that means it's 11 Newton, 2SF. Okay. And then what should be the direction of the net force? So it's initially dropping and then it will rebound. So that means the net force should be upwards because it rebound, okay? So it's upwards. Then otherwise, Otherwise, you may just think it like that lah. Otherwise, you may think it like the object we bound MV minus MU, okay? MV is upwards, MU is downwards. And then in terms of the vector, upwards vector minus the downwards vector is the upwards vector plus the upwards vector, and then give you a upwards vector. So the resultant force should be upwards. And then the other two marks explain where the linear momentum is conserved during the collision of the ball with the floor. Yes or no? Conserve or not? Conserve or not? Conserve or not?
No.
No,
No,
because this changes.
because
The approaching whatever is different from
The
Ah.
relative speed of approach is
I don't
not
know.
the same as relative speed of separation.
so many of you forget how to do these kind of questions. You say linear momentum is not conserved only if the net force is not zero. Let's finish.
Let's see.
Oh,
You
so
can
it's-
also talk about the
Wait, can you go back?
what is conserved. It's conserved. It's conserved.
Is this
Wait,
a
what's
marking
the
scheme? Mhm.
Let me calculate the kinetic energy.
No.
No, energy might not be conserved.
The
but
kinetic
momentum
energy
is
is not conserved because the speed is not the same.
Now, the momentum is. I think the question does not say it clearly, because if I just consider the linear momentum of the ball, then it's not conserved.
Yeah, but the ball and the floor system then is going to be conserved because there's
Yes.
no overall change there's no external force.
But the question does not state whether the linear momentum is the ball or the ball and the floor. So if you're just talking about the ball, and then you say the linear momentum of the ball is not conserved because the net force is not zero. If you are talking about the ball and the floor, and then you say that the momentum is conserved. So the question is so I don't know what to say. So it may be better for you to write it more clearly. You say the linear momentum of the ball is not conserved because the net force acting on the ball is not zero. Otherwise,
But in the marking scheme, it doesn't say anything about the ball. So would we get a mark for it?
maybe you lost 2 marks because the question is unclear. So I can't help if the question is unclear. So you may say
it's just 2 marks.
of the ball and the floor. Okay, we just leave this question. I hope.
Okay.
Next one, what was means by elastic potential energy?
It is the energy stored in a spring when it's extended or compressed.
Yeah, so let's have a look and then you remember the answer.
Wait, can you go back?
To which one?
He'll paste it.
Oh,
Okay. So next one, show that the spring obeys Hooke's law for this range of extension.
Constant gradient.
Yeah.
Yes.
And then, but does it pass through the origin?
no.
No.
Yeah, but that's for CM. It doesn't show extension.
X is X, extension already.
No, is it extension? Doesn't. Oh, okay.
Yeah, it says it at the top.
So you, now first of all, you say that it has a constant gradient. And then you also need to show that it passes through the origin. So how can you show that pass through the origin? Hello. How can you show that it passed through the origin? Hello, hello.
I don't know.
Wow, okay.
We can like take a point, and then we can assume for x if it's like 0, and then we can put like y as like a finding value. If we get y as 0, then it passes through the origin.
Or maybe you can just pick a point and compare with 0, 0. If the gradient is equal, then.
No, it's just mathematics
Possible.
question, actually. So if you have a log here, okay, and then you have 2 points on the graph, and then you just find a point with the x equals 0, and then find the red y coordinate. You should know how to do it in mathematics. So let's say, okay,
Y equals to mx plus c.
yeah, and then you need to show that the vertical the intercept is 0. So another way to do it is to find f over x to see whether these 2 points have the same f over x. If they have the same f over x, that means it passed through the origin. So it's 0.26. So I'll give you some time to look at the marking scheme here. Okay. Now, no question, then let's go on. For next part, find the spring constant. That means you find the gradient of this graph. I think you have already find it, so it's 0.26. Okay. So how can you find the work done from 20 cm to 40 cm?
Area under the graph.
Area.
Yeah, you just find the area under the graph. So, and keep it in mind, the graph is not starting from 0. So that means, indeed, not just the area of the graph. but you take you need to starting from 0. So that means what's the point here? 10.4. Is it 10.4? So the area should be 5 plus 10.4 times 0.2.
係5開始。
Oh, sorry, it's not starting from 5. It's starting from 5.2.
4.
Oh,
2. I don't know.
2. Yeah. Okay. And then you can get the work done. Not difficult, is it? For 3
So
marks,
how is
oh,
the
just find
height?
the area. Huh?
Wait, how is the height 0.2?
5.2. The width
No,
is
no.
2. 40 minus 20.
Oh yeah. Okay. Oh, it
divided
has
by
to be in meters.
Yeah, everything should be in SI unit.
Okay.
So, okay, and then you can get the answer. Okay. Wow, you get 3 marks for just this kind of question. So easy, huh?
Yeah, but we already lost 2 marks for guessing the weight of
Aye,
the
okay.
mass of
Never
something.
mind. Now, a force is pi to extend to 50 cm. States how could we check the spring has not exceeded the elastic limit?
Check its K.
No.
So,
Yeah.
Do you remember what does mean by elastic limit?
A
No.
point from where it's no longer proportional to
No.
like the proportionality.
That's the point of proportionality.
so like when it's not constant anymore.
No, many of you forget huh? Forget huh? Okay. Elastic limit is the point where if you exceed this limit, and then the length of the spring will not return to original length when you releasing the load. So you just first of all you release the load. So if it will return to original length of the spring, and then that means it is not exceed the elastic limit. So let you have a look at the marking scheme. So we remove the force, that means we remove the load, and then the spring will go back to its original length. Okay. Wow, many of you forget, is it? Okay, and then let's go on to the next question. First of all, find the frequency on this graph. What is the period in this graph? Period.
The period is
Oh,
4 ms.
ms. Yeah, you need to take care about the unit in the graph. So it's 1 over 0.004 is the frequency, or you just say 4 times 10 to the power negative 3. And then you can get the frequency is 250 hertz. Okay. Part B, second wave with the same frequency. Also pass the points. The phase difference is 90 degrees, and then Z had the intensity 2I. So, wow, 3 marks only. So first of all, what is the amplitude of the second wave Z? Hello?
Wait, we can calculate.
wait. Where is point P?
No, it doesn't matter. No, it doesn't matter where point P is.
Okay.
Do you still remember what is the relation between the intensity with anything?
Or amplitude square, something like that.
Yeah, so
Distance something.
intensity is proportional to amplitude square. So can you get the
Or 1/. What is that? Phase difference of two wavelengths. Oh. So does it?
So have you find the amplitude of the wave set? So it's proportional to intensity. That means the intensity of set over the intensity of xc equal to amplitude of set square over the amplitude of x squared. That is 2 square. Okay, and then you can get the amplitude of set should be 2 times square root 2. So give you 2.8. So any question?
Wait.
What?
Hmm?
What?
No? Do you have any question?
Wait.
No question.
Okay. If no
Okay.
question, and then let's go on. So how can you draw that graph? So it has a phase difference by 90 degrees. So it's either you can draw either like this one, but amplitude is 2.88 r. That means here you can either draw it like this one. Oh, so I rather you put all the points first, okay? Like what I did. Yeah, just fuck you.
180 degrees is a whole wavelength, right?
Hmm?
A 180 degrees is a whole wavelength.
No,
No, half.
360 degrees the whole wavelength. You just consider a circle. A circle
So,
means one wavelength.
So 90 degrees is just a quarter.
Yeah, a quarter.
Yeah.
Okay, if you put all the point, it should be something like this one. Okay, something like that. I can't draw better. Actually, there's another answer. So yeah, if you upside down it, and then you get both answer is correct. But can any one of you explain why this both answer is correct?
Because
It also shows like 9 degrees back.
Still 90 degrees.
So
is it
it's
because it's
90
like difference of 90 degrees? So it doesn't matter forwards or backwards?
Yeah, it doesn't tell you whether Z is forward or X is forward. So if you look at the marking scheme, it's either left or right, okay? So that means both of these graph is correct. Okay, let's go on. Oh shit. I need to charge my MacBook. It's 3% now.
Yeah, it's okay.
And then
Okay,
it
suddenly turn off.
and then it go to 0% and then you won't see me lah.
Yay.
Yeah, I want to see the.
So let's go on.
Sometimes
You want to see my computer to go to 0% battery. Okay. Let's
No.
Let's see what happens.
it actually still works.
Hmm?
It's really weird.
Okay, let's go on to this question. So it's the relation between x and d. X is the fringe width. So you have that formula in the formula booklet. X equal to lambda d over a. Okay, a is 0.45 millimeter. D is given. Lambda is a wavelength. Okay. Use the gradient to determine the wavelength in nanometer. Oh, let me have a look. Wait. Okay. This graph actually passed through the origin, so it doesn't matter. So if you find the gradient, then you get the value of x over d. X over d. X over d equal to lambda times over a. You just rearrange this formula. And then the wavelength can be written as a times the gradient of the graph. So a is 0.45 mm. And then times the gradient. So can you finish this question by yourself?
Oh.
Have you finished? Find the wavelength. Can you finish?
There's a value of x 4.8.
It's so hard to, find 2 points.
Let me enlarge the graph, okay?
Times 10 to the power of negative 7.
What do you get?
3.6 times 10 to the power of negative 7. Is it too small?
8.6.
Oh, in nanometers. Oh, never mind.
8.6 times 8.6?
3.6. 3.
Oh, 3.6. Otherwise, you're out of the visible light range. So in units of nanometer is 360 nanometer.
What color is this light? What does it say?
I think it's around.
Wait, but isn't like 360 nm like smaller than the visible wavelength?
Really?
Isn't it 4 to
Because
7?
it's from 7. It's from
7,
4
7.
times 10 to the minus 7 to 7
Yeah,
times
might be too small.
7.
So let me check your answer.
I got something else.
Yeah, I
Okay,
got something
so-
else.
Yeah, definitely. I'm probably
Same.
wrong.
I got
What do you
something
get?
else.
Yeah.
What do you get? What do you get? Hello, hello. What do you get? Hello. Everyone, what do you get?
I don't know.
Wow. Ay, like, let's do it
What's
together.
the just tell us the answer and we will see if it's correct or not.
So if you look at the graph, it's better for you to take
go
a
That's
nice
better than
point.
mine.
But there's no nice point here. So you take like this one, okay, around 4.8 mm. That means you divide by 1000 and then divide by 3.5. That is x over d times a. A is 0.545 mm. And then take out your calculator.
What was that?
She says
Huh?
Monday and Wednesday this week, so not today.
Why do you just use one
Wednesday.
point? Why do you just use? Oh,
because
I
it's
see.
not
It's
our-
I'm
zero.
asking about next week.
Actually,
Yeah,
it's possible.
never mind.
It's
So-
from
You get 6.2. Okay, 6.2 times
9 to 1.
7.
No way. Let's go.
Huh?
Yeah,
Yeah,
that's all right.
I got that.
Finish
It's a week,
carry,
it's a
please.
week.
Can you see the marking scheme?
Okay.
I mean, can we see?
Trust me, a minute. Oh,
Same
Harry.
thing that I did when I
Harry
That's right.
when I went out for the other thing.
Yeah, they will
Come
give
back
you
and
a
do it
range
all.
of answer.
Or do some of it while you're still at school because you can.
What?
Hmm?
I'm confused.
Where is confused?
No. From what? Nothing.
Looks like it. I know it's supposed to be twice, but I'm not going on once. Not going twice a week. That's insane.
Wait, what?
I think because we can hear
I'll
Mike.
go once a week, if possible. Yes. Okay. So I'll go Wednesday.
I can only tell you this Wednesday.
Yo, Micah. Me.
Micah, are you okay?
Oh, sorry. My bad.
Okay. Okay, then let's go on. The separation of the slit is increased. State and explain the effect, if any, on the graph 5.3. The separation of the slit increased, but the wavelength still the same. So look back to this formula. That the state of the slit means that A decrease. So X over D should increase, okay? So that means the gradient of the graph increase. And then the value of X will also increase because D remain unchanged. Okay.
Hold on. Stay here.
Sir, why did the A decrease?
Oh, I say A increase, okay? Okay. Any other question? Any other question?
Sir, is my
Nope.
log better?
Huh? What do you mean you are not there?
No. Is my voice clear now?
No. No.
Okay.
Is less clear now. Lol.
It's less clear. Nice.
Is it okay? Then let's go to next question. Or any question? Hello. Hello. Hello.
Hello.
Then let's go to next question. Or define Coulomb. So what formula do is related to Coulomb?
Q equal IT.
Ampere times time.
Q equals to IT, MIT.
Yeah.
Bars.
Oh, the charge is current times time. So you define Coulomb. It's not like those defining the quantity. So Q equal I times T is just the product of 1 ampere current. So you say it's a charge of 1 ampere current in 1 second. Okay, so 1A times 1 second give you 1 Coulomb. No question. No question.
No.
NAR.
No.
No, let's go on. Show that this one. I think we have done this in the class. Did we? Do we?
I think so.
So I think we don't need to do it.
Oh yeah, we did.
How to do,
No.
how to do. So
No,
Wait,
do it. Do it. I don't
Yeah.
know.
No.
yeah, she doesn't know. Do it.
Do it.
You cap screen and then
Copy paste. I can't do that in
Wait.
exams.
For Coulomb, you can just write its unit and you get the mark.
yeah.
Oh.
1A times 1. So you say amperes. It's better for you to write is 1 ampere times 1 second. So let's go on. Like this one. I think we have done this question. I think we have done this question. So
Yeah.
let's say, yes, we have definitely done it before already. So maybe I give you some time to do the C1. C1 is a little bit difficult, maybe. Done it? So anyone finish? No one is speaking. Have anyone finished?
Is it 4?
Let's check the answer. Yeah. So you need to use this formula. And then if you have looked at this formula, they have the same currents because they are in series. So the drift velocity is a formula I over NAE. So, and then the ratio should be I over NAE, I over NAE. And then they have the same current. They're made of the same material. That means they have the same number of free electrons per unit volume. E is the charge of electron, so they should have the same E also. And then that means the ratio of the drift velocity should be the ratio of the area of Z divided by area of Y. And then Z has the diameter double, so it's 2 squared over 1.
Wait.
So it's 4.
Yeah.
Yeah, it's right.
Oh. Oh.
Yeah.
Okay. Show that the resistance Y over Z is 2. So this one, you need to use the relation of the
Isn't it
formula.
like the resistance formula?
Yeah. So they are made of the same materials. That means they have the same resistivity. So the ratio should be the ratio of the length Y is L, and the area of Y, length of Z divided by area of Z. So give you 1 over 2 times area of Z divided by area of Y. And then it's 1 over 2 times 4, give you 2. Okay.
These questions look so complicated, but they're not really that complicated.
Mm-hmm. Okay, let's go on. Determine the potential difference across Y. You use a potential divider. So the ratio of the resistance is 2 to 1. And then the potential difference across Y is just the ratio. That means it's 12 times 2 divided by 2 plus 1. And then you get 8 volts.
Why 2 plus 1?
The ratio of potential divider.
Oh, okay.
Small r and big R. And give you the potential difference across the small r.
Okay.
If no question, and then let's go on to next question now. So find the ratio of the power. Now they have the same current. So it's better for you to make use of this formula, I squared R. They have the same current. That means the ratio of the power equal to the ratio of resistance, because the I can cancel out. So the ratio of the resistance is 2. So the ratio of power also should be 2. Simple.
Mm-hmm.
Okay.
Yeah.
No question. Let's go on to question 7. Give one example of hadron,
Proton.
proton, or neutron. The easiest example. Example of lepton.
Electron.
Electron.
Yeah, positron,
Neutrino.
neutrino. Okay. Describe in as a simple quark model. A proton is
Up, up, down.
yeah, and then neutron is
Down, down, up.
yeah. So computing the wow, this kind of question is really easy. You get 3 marks already. Wow. The beta particle may be emitted. Okay, this is beta decay. Word equation. Okay, not symbol equation. So this one is proton plus electron, or either you say beta or electron, and then another one is
Antineutrino.
antineutrino. State in a change in the quark composition. I think we have done this question already. So if you look at the part 2, okay, one down become up. Okay, one down quark become the up quark. Yeah, and then you get 5 marks. So easy. You can finish it in 1 minute. Oh, is that the last question?
Yep, radioactivity is always less.
Okay, and then I've done all the past paper already, and then I need to give the names. Okay, and I'll send you I'll send you all the homework for these 2 months in 30 minutes. Okay, and then you can start to do the question paper two from now on. Okay, any question?
Are we going to school this Wednesday for the practicals?
Yes, I will send you also the same. I will also set the time in the setter. Okay, so you have the grade A star, A, B, C, D, and then they represent different time slots.
No.
Okay, they are not graded. Okay, they are not graded.
It's
No.
okay.
Okay. No
But-
question, huh?
But sir, why can't you send like a Word file like how Mr. Yip did? Or like any of those?
Yes, I just put it in data so that you don't have any excuse that you don't know what you don't know about your time slot.
Then can you like write in the description A star means whatever?
Yeah, I will do it.
B, C,
Also,
whatever.
I'll send you a Excel, or I'll just send you a photo or the web file about which one go to which time slot. Okay. Maybe let's see you on Wednesday. Okay.
Okay, bye.
But Wednesday we don't have lesson. I mean we don't have the live lesson. Okay. Instead we have the practical. Okay. See you on Wednesday. Bye bye.
See you. Bye bye.
Bye.
Sir.
Yeah.
I have a practical lesson in school already on Wednesday. So what time will it be?
What subject? And when is it?
Art from 9 to 1.
Okay, I'll assign you after 1. Okay. Maybe after 2 or 3. So you have your lunch
okay.
and then you come back.
Sure.
Okay. Bye bye.
Adios.
Bye.